Now we're going to use all these rules we've come up with to analyze a complex circuit. So a circuit where it's not just a few resistors in series, or 2 resistors in parallel, or 3 in parallel. It's mixtures of series and parallel. So we'll start with a 12-volt battery. We're also going to use actual numbers this time. And a wire comes up, and we have a 1 ohm resistor there, a 1 ohm resistor there, 2 1 ohm resistors there, 1 1 ohm resistor there, and then that completes the circuit and it goes back to the other side of the battery. So we're using numbers, we're not getting too complicated. All the resistors are 1 ohm. Like that. Okay, and then the question is, what is the total current coming out of the battery? There's one question. We're going to then answer multiple questions. But the first one is, how much current comes out of the battery? So we remember that the battery doesn't know what's going on. The battery just senses some current. And the battery says the EMF for the battery equals the total current that comes out times the equivalent resistance. So if we're going to find the total, we know 12 volts. If we're going to find this current, we need to figure out what is the equivalent resistance of this thing. So R EQ, and now we can't just use either of the parallel or series formulas independently because both things are happening. So to do this, the easiest way is just to look at it and start just thinking about it, because, that's a terrible thing to tell you. Just start thinking about it. What you do is you apply the ideas of parallel and series, but you don't have to just apply them to the entire circuit. You can apply them to individual chunks of the circuit. So what you can do is start sort of taking this apart and drawing it as though it's different circuits, or thinking of it in pieces. So for this one, I would think of it as 3 things in series. This is in series with this, is in series with this whole thing. Because series means it never, there's never a junction. So if you move along, the first thing you hit is a resisting element, and rather than a junction, then sort of the biggest picture is that it's in series. So I would probably start by labeling these. We'll call this one like A, this one B, and this whole thing C. So if you think of it that way, you could say then the equivalent resistance is 1 ohm, that represents A, plus 1 ohm, that represents B, plus whatever this is, RC. Whatever that branch equivalent resistance is. And now we can think about the branch, like what is it really? It's 2 resistors in series, but on this side it's 1 ohm, and on this side it's what? It's 2 1 ohms it's 2 branches in parallel. One of the branches is 1 ohm, the other branch is 2 1 ohms in series. Well, what is 2 1 ohms in series? 2 ohms. So now we're going to, for C, then we're going to redraw it like this. 1 ohm and 2 ohms. So there we sort of thought about 2 things at once. This whole thing in parallel, we went ahead and just summed those together in our head real quick. Little steps. So what's 1 over RC then? Because since it's in parallel, we're going to say 1 over RC is 1 over this branch, 2 ohms, plus 1 over 1 ohm. If you want it to be completely thorough, you could write 1 over 1 plus 1, if you wanted to not immediately jump to calling that a 2. But you'll get there. So what is this? This is 2 over 2, this is 3 over 2. So you say, oh, it's 3/2 ohms. No, remember, flip it back over. RC, 1 over RC is 3/2. So RC is 2/3 of an ohm. Okay. So going in series tends to increase resistances. Going in parallel branches tends to decrease resistances. So one way you can sort of check your math as you're doing these is if it's 1 here and 2 here, the equivalent resistance of these things in parallel is going to be less than both of them. It's going to be drop lower than 1 and drop lower than 2. And sure enough, 2/3. It's lower than than the 1. Okay, so now all we got to do is plug that into here. And we say R, the equivalent resistance, is 1 plus 1, 1 plus 1 plus 2/3. So that's 3/3 plus 3/3 plus 2/3 is 8/3 ohms. That's all the battery knows, 8/3 ohms. So if we want I total, then we say 12 volts. Now we're doing this equals I times 8/3, and I will come out in amps to be 12 times 3 is 36, over 8 is 4.5 amps. So that's how much current comes out of the battery.